Hello students, hope you are doing well. Uh, Today we will discuss few questions from heat and thermodynamics chapter. Basically the first part of the heat that you have studied was on calorimetry and heat transfers. So we will try to solve few questions on this topic. I have taken these questions from various places. A few questions are tough, but those questions are relevant to your JEE advanced preparation. So what you can do, the pattern will be I will first read out the questions for you. Then you pause the video for 4 or 5 minutes. You can take this time to solve this question by yourself. And after that again you come back to the lecture and see what is the solution or whether you have got the correct answer or not. And if you have solved this question, please mention how much time you have taken to solve this question in the comment below. So the first question is, a wire is made of different alloy such that its thermal resistivity varies with its length in a sinusoidal curve as shown in the figure. Find the temperature of the middle of the wire in steady state if its ends are maintained at temperatures 100 degree and 0 degree Celsius. There are 4 options. You need to choose in between the options. So you can try by yourself and again come back to see the solution. So I hope you have given a good try to this question. So let us see the solution of this one. As you can see, this is the rod it is talking about. These two junctions T1 and T2 which are maintained at 100 and 0 degrees Celsius respectively. In this direction I have assumed the x is increasing and this is obviously x equal to 0, middle point is x equal to L and this point is x equal to 2L, right? So I can see the total length is 2L from this graph also. Now from Fourier's law of one-dimensional heat flow, we know that the heat current which is dq by dt is minus k into A into dt by dx, right? So K is the thermal conductivity, A is the cross section area, dt by dx is the temperature gradient. The negative sign, you all know that it is because the temperature decreases along the x. So if I try to write down the same equation, I have just denoted dq by dt as I. So dt will be in numerator, so the temperature difference is T1 minus T2 I have taken, so I have omitted the negative sign, right? Dt should be ideally T2 minus T1, with the negative sign I can write it T1 minus T2. I hope it is clear. And in denominator I can say 1 by k into dx by A. It's like the resistance equation in current electricity whatever you have studied. But here in this question the thermal conductivity is not given, instead they have given thermal resistivity rho, right? So I can write rho is equal to 1 by k. So this equation becomes T1 minus T2 divided by integral of rho dx by A. Now this denominator part is entirely the resistance. I need to calculate this one, and A is constant. Look here, area is constant but resistivity it is varying. So I can take this A in the numerator upside and in denominator I only get it is integral of rho dx. Now from this graph, initially it may seem to be difficult because how to solve this resistance if I have graph of resistivity, but now you can understand that integral of rho dx is nothing but the area under this graph, and the area under this graph is also very easy to calculate as it is a sine graph. So above the mean line, average rho naught, whatever is area above it, the below area is the same thing. So I can say that instead of having this curvy area, I can have a rectangle of this one. This will be plus and this will be minus, right? So instead I will take this rectangular area as the integration of rho dx, right? So that is area under rho x graph, which is rho naught into 2L. So that gives me the total current. But as the current is everywhere same, so if I try to write down the same Fourier's equation, not in between T1 to T2, but in between this x equal to 0 and x equal to L, I should find the same current expression. So here I have written this equation from 0 to L, and I have assumed the temperature at this L to be T, TL. So I can write it is T1 minus TL into A divided by integral of rho dx 0 to L. Now please see that this integration rho dx from 0 to L is not a rectangular area. This is integration of 0 to L, its area under this graph. So this area combines one rectangular portion and another portion inside the sine graph, right? So I need to calculate here. I have separately calculated this area here. Now I can write the function of rho as a function of length. Length is x, I have assumed. So rho versus x graph, how do I find it? From this graph I know that this is the amplitude of the sine function, right? The amplitude is equal to rho naught by 2, because this is rho naught and this is 1.5 rho naught. So rho naught by 2, and I can say it is rho naught by 2 sine pi x by L. At x equal to L, you see that there is a pi. If this were a theta in x-axis, then this would be your pi, right? This would be your 2 pi. This would be your pi by 2. So when theta is equal to pi, your x is equal to L, right? So I can write the sine function as sine pi x by L. And obviously this rectangular part has rho naught into L area. So when I integrate it from 0 to L, this integration is easy. You can do it by yourself also. So rho naught L plus rho naught by 2, and this will be L by pi into minus cos pi x by L. When you put the limit from 0 to L, this entire integration comes to be rho naught L into 1 plus 1 by pi. Now you can compare these two equations. These two are the same thing. So 100A by 2 rho naught L is equal to A into T1 minus TL. T1 I know it is 100 minus TL I have to calculate, divided by rho naught L into 1 plus 1 by pi. This area I have put here. Now after solving, you can find the answer of TL is 15 to 1 minus 1 by pi, which is approximately 34 degrees Celsius. So option D is your correct choice. This question is also a very good question. I have got this question from some Olympiad book, I think. But it is not that difficult that you cannot solve it. Any JEE aspirant can also think about the solution of this question. That is why I have taken this question in this module. So I will read out the question again. You pause the video and give it a try and come back to see the solution. This question says, the filament of a halogen lamp has length L meter and is made of tungsten. At the working temperature of the lamp, which is T0, the density of the tungsten is rho kg per meter cube, and the specific heat C joule per Kelvin kg, and the resistivity is rho EL, means electrical resistivity is rho EL ohm meter, and when a voltage of rectangular waveform as shown in the graph is applied to the leads, the temperature of the filament will reach the nominal value T0. Strictly speaking, this is the average temperature. The interior region is slightly hotter, right? So basically it is talking about the surface temperature, right? Interior region is slightly hotter. However, due to voltage oscillations, there are small oscillations on the filament's temperature. Why? What is the amplitude of this temperature oscillation? You have to find it. It is given in some numerical form, so you have to calculate the value of n actually. Right, so the question says, I will try to explain the question to you again, that this is a filament whose resistivity and density also is given, and I apply this voltage function, right? It is a rectangular voltage function is applied, then the temperature of this tungsten of this filament increases, but it oscillates. What is the amplitude of this oscillation? You have to calculate. So let's give it a try and then again come back to see the solution. I hope you have given few time to solve this one. Now let us see the solution of this question. So few things I have written here. Let me explain this. This is the waveform, rectangular waveform that is given in your graph. I have drawn that here. Now you can see one thing, that when I start heating this filament, its temperature starts rising from certain value, say theta naught, and it rises up to this value theta max. What is the function, what graph it follows, that I am least bothered about. I only have to calculate the amplitude of these fluctuations. So its temperature rises from theta naught to theta max, and as soon as I switch off the power, this temperature decreases. Why the temperature decreases? Because it emits heat by radiation to the surrounding. Its temperature decreases, comes down to the same theta naught. In this time interval, time intervals are given in your diagram. You can see it is t by 2 time, it is t time. After t time, again you apply voltage, its temperature rises, and this keeps on going. So let us break this entire situation in different steps. The first step is from 0 to t by 2 time. In this time interval, what is the power, what is the total energy you are supplying to the filament? You can say it is v square by r into dt, integral from 0 to t by 2, where r is the resistance of that filament. You can easily calculate the resistance from the given value. But this power you are supplying to the filament, by the same time, the filament also loses power, loses energy to the surrounding. Mostly I will consider this to be radiation, because it is not mentioned that it is in contact with something else. So by radiation it loses power. Now what is the function of this energy dissipation? That is not mentioned in your question. If it is clearly mentioned radiation, then I could take a function of temperature to the power 4 or something different function like the temperature difference, it directly proportional to temperature difference, that I could take. But here it is not mentioned and it is not needed to solve this question, so I can assume it to be any function f theta. Theta is the temperature, so it depends on its temperature definitely. As its temperature increases, so the radiation per second, that will also increase. and that will also go on from 0 to t by 2 second. So this is the power input, this is the power loss, and the resultant power will increase its temperature according to ms d theta equation. So again, try to understand what I have done. This function is the energy that is input to the filament. I have written it to be EI. This function is the energy lost due to the radiation. I have written it to be minus E naught output, or you can say that is equal to the total heat received by the filament during this time, delta Q, effective heat you can say. Now when it's losing the energy in from t by 2 to t second, you can see there is no source of energy, so it will only lose the heat to the surrounding, and now it is from t by 2 to t second. And one thing you have to understand, that the function it followed in this time period to lose heat will be the same function it follow, because the heat radiation, it will follow a particular function, so the same function it will follow, and more or less the temperatures are also the same. If you see that I am integrating f theta dt here in the first case, so theta may be, suppose let us take one example, say 50 degrees Celsius, 100 degrees Celsius, 200 degrees Celsius, 250 degrees Celsius, like this. When it comes down, it will also see the same temperatures. It will not see 300, 400 or different temperatures than this first graph, right? Only difference is that earlier it was first seeing lower temperatures, then it was having a higher temperature. Now while coming down, it will first have a higher temperature, then it will see a lower temperature. But if I integrate this entire function, I should find the same value. So that is why when I have written it to be E naught, this is the same E naught I can write, right? And that is equal to ms d theta, but here theta will vary from theta max to theta naught. So I can write this function that from 0 to t by 2, whatever energy it has lost from t by 2 to t, also it will lose the same amount of energy to the surrounding, right? So that is why the second equation I can rewrite as minus E naught equal to minus delta Q. If this is delta Q from theta naught to theta max, when the integral limits are opposite, this should be minus delta Q. If it is clear, then the rest of the question is easy. You can now add these two, and you can see that this is E naught equal to delta Q. So if you put it here, you will find E naught equal to EI by 2, right? And that is equal to delta Q, right? So what is now this EI? I know that EI is this one. I do not know what is the value of E naught, but I know that in terms of EI, what is the value of E naught? So what is the value of EI? EI is simply V square by R dt. V here is U1. This value is U1. It is constant till 0 to t by 2. So I can take it outside the integration. U1 square by R into dt. What is R? R is the resistance, which is rho electrical into length divided by area, right? So I can use this one as EI. So E naught is EI by 2, right? So EI by 2 multiplied by U1 square by R into 1 by 2 into the integration of dt is definitely t by 2, and that is equal to delta Q, right? E naught equal to delta Q, and E naught is EI by 2. So EI by 2 is equal to delta Q, and delta Q is equal to ms into theta max minus theta naught. And I can write from here what is theta max minus theta naught is equal to this square u1 square into t divided by 4r. I have missed m into c term here because s is equal to c is given in your question. So what is now the amplitude? Look, this is the maximum value, this is the minimum value, and in between there is some average value which it is mentioned in your question as T naught, right? The average value. So this maximum and this minimum, half of that I can consider to be the amplitude, delta theta, right? This is the amplitude, half of this. So theta max minus theta naught by 2 is the delta theta. So this is u1 square t divided by 8r mc. You can put the value of r mc. I think r is this one, and m is equal to rho into L into A. So the denominator part RMC will be is equal to A gets cancelled out, rho EL into rho L square C, right? And there is obviously a term of 8. So the answer to the question what is n is equal to 8. That is the answer. So just see the solution again and again. If it is not clear at the first time, you again and again see the solution. And it's very natural that whenever you are seeing a solution and thinking about it, there may be some doubt that might crop up in your mind. So don't forget to leave those doubt in the comment box below. And whenever I will find time, I will definitely try to reply your doubts.